Hello and welcome to another episode of Anything Arduino. Again, I need to apologize for the long interlude between episodes. As been said before, life is complicated and above all, time consuming. So enough with the apologies and let's get to it instead. So in the last episode, a long time ago, we talked about these two modules, the sender and receiver on the 433 megahertz radio frequency. And today I want to add to this. I'm going to stay in... we're actually not going to work with an Arduino today. We're going to make a button. If you've seen these before, these also used, I showed this the last episode as well. It's they're used for, you buy them really cheap to turn on and off those chip switches. We have one here which I've taken apart, but those radio controlled switches to turn on and off, for example, lamps, as I showed you in the last episode that you could do with the Arduino. This time we're going to do the other way around. So we're going to do one of these, but not with all these buttons. We're just going to make one small button that will have a battery that will last forever and that you can put anywhere. And with that small, hopefully small footprint build, you can send commands to the Arduino, and with that you can send commands to anything, because with an Arduino you can control and connect to anything. So Kickstarter is swelling over with those small buttons, that Internet of Things or Internet buttons or all those kinds of things that you have a button, you place it somewhere and you can do anything with it. And you need a proprietary software and yada yada yada. This will kind of do that, or actually it will do that, but you will need an Arduino to receive the signal and to do it. So in these, if you open up one of these, it looks like this without a few cables that I put there. And in the center of this, there's just a lot of push buttons, and then there's in this one HX, but the normal one is called PT2262. So it's a really old chip, and you can buy it really cheap, a 10-pack for just a few dollars on eBay, for example. And with this and one of the application notes in the datasheet, we are going to make one of those buttons that will last forever. So let's go and look at the schematics first.
The PT2262 is quite a simple chip to work with to get it to send commands over 433 megahertz band. It's most pins are address and data pins, and rest is so there's two pins for the oscillator that decides the frequency of the data sent, and then you got the data output pins, and TE is transmit enable, and you got ground and voltage plus. So that's basically it. The only slightly different from normal chips is that the address pins are what is called tri-state. So instead of the data pins, if you want to use the pins as data, you can use, as you can see, from A6, A7 through A11 is shared with digital 0 through 5. And if you want to use the data, the pins as data, then it's only binary, so a 0 or a 1. But if you want to use them as address pins, then they are tri-state. What that means is that a binary, if you remember, is a 0 or a 1. A tri-state. So binary is a 2-state pin, and tri-state, then you still have the 0 when it's connected to ground, and a 1 when it's connected to plus voltage, and in the middle you have a F or a float when it's not connected to anything. And this way you get way more values out of each pin. Each pin is a factor of 3 instead of 2. So with all these pins as address, you can have up to 500,000 different addresses. So very many values that can be sent. So you're not going to have 500,000 of buttons in your house, and not in the neighboring houses either. So this is a good way of not running out of headroom for the addresses. Now the circuit we're going to build is from the datasheet. It is one of the application circuits that they describe. So this is the UHF band address only, 0 data, 0 standby. 0 data is because none of the address pins are connected, I'm guessing, and we have no other data pins you can connect. In the remote there are loads of data pins connected. As you can see here, here's 4 switches for 4 buttons. So this is another circuit in the datasheet. But we are going to make this one, a really simple one with just 1 button, and that's it. This doesn't mean that you can't. You can set any address here, but it's just soldering these to either plus, minus, or leave them floating to get many different buttons. And as we see here, here's the oscillator pins. We connect a 4.7 mega ohm there, and this here is, as far as I can tell, the transmitter module. So everything here is in the transmitter module already. We just connect the 47k ohm and an LED to show us that we're sending. And the reason it says 0 standby is the switch is here between the plus voltage and all the other circuitry. So what this means is, as long as we don't push the button, no power will be drawn from the battery. And that's why I say it's almost limitless for how long this will work. So with this, let's start building this circuit. So we start by putting the PT2262 on a breadboard. And we also add the antenna module. So then we add the power. We do like this. We put them up here in the corner, plus and ground and plus. Actually, we only set plus up here. Ground we can connect directly. Ground. So ground on the PT2262 is on pin 9, and then we also add it to the sender like that. We are going to need a button, so we place the button over here. Like so. And that button is going to go from plus voltage So we have plus voltage there, and it's going to go to voltage in on the PT2262, so pin 18, and also it is going to go to an LED connected to the let's see, it's connected to voltage in on the antenna module. Then we have a small, the 4.7 mega ohm resistor should be between pins 15 and 16 there, and that is for, I believe it is for an internal oscillator in the PT2262, at which rate it should send the data packages. And we should also have the 47k ohm between pin 17, which is data out, so 47k, and to the data in, let's see, there, the first pin on the antenna. So this is where the data comes. So from 17 to data on the antenna. And then we also need a pin to pin 14. 14 is TE, transmit enable. So once we connect pin 14 to ground, which we also want to do, that can actually be connected all the time. That is no problem. It can be connected all the time because we only transmit when we press this button. And I believe that is the whole circuit. So let's see what happens. That happens, and that is wrong. So there, I had just turned the button the wrong way around, so the circuit in itself was correct. It was just this button that was turned the wrong way around. So now when we press this button, we are sending whatever address we have put on here. And as you've seen, we haven't changed any address. If we want to change the address, we can do simply just adding a wire to between, for example, pin 1, which is address 0, to ground, which will get another address. In the interest of time, I need to stop here and just say that after this video became, or I recorded a lot of video material for this, because after this prototype that you just saw, I sat down and made 2 real buttons. These are prototypes as well. You see it in here. I crammed as much as I could. This was from the beginning thought to be like this, but I managed to cram it all into this little box. So this is more like a door button if you want to have something working at the door, and this was meant for a small pocket size that you can just carry with you in your pocket. And then I'm going to go through this in a minute, how I wired this. So what I'm going to do now is we're just going to go through the code. I'm not going to go code while I record. I'm just going to go through it
So you will see what I've done with these two buttons and how to make your Arduino do a lot of stuff on the internet and in your home if you wish to have one button that does loads of things. So if you want to see my build on these two, I'll put those videos up. It's like a 2 or 3 hour video of me sitting soldering and trying to fit as much circuitry as I could into small compartments. It's not that great entertainment value, but I'll put a description, or I'll put a link in the description to those videos for those of you who want that. So let's just go into the code and I'll show you that as well. So the code is very simply the receive demo simple. If you look at the beginning here, it is almost the same as here. I need to add some definitions for the OneShield for Twitter, and I also need to include the OneShield library, except for the RC switch. Then I begin my switch there, and this is because I want to turn the lights on and off with one button. This is the pocket switch, switches between on and off. And I kept the serial stuff, and then we enabled the receive on interrupt 0 and the transmit on pin 10. And interrupt 0 is the same as pin 2. I go through this in the previous episode 24. So if we find any key presses, we get the value, and then we have figured out the values of the this is the doorbell button, and also we figured out the value of the pocket button. So these are the two values. And if we press the doorbell button, then we serial print, and then we tweet. And this is just the standard tweet, but actually what one could do, one could create a Twitter account called Christian's Doorbell, and that doorbell could tweet to me, Sorcery1. There is someone at your door. Go open it. So this is what you could do, and I'm going to go through another episode where I explain how the OneShield works. It's really simple. Just uses a Twitter account that you log into on your phone, just as normal, and this just tweets to that account. So every time someone is at my door, I will get a tweet. Interesting for everyone in the world to know that someone is at my door. So anyway, if we instead press the pocket button, then we do this. And if the pocket switch, that's what I showed you before, is 0, then we're going to turn it on. So, and this because we have both a receiver and a sender, and the receiver interrupts as soon as the receiver gets a signal, it sends an interrupt and stops all other computing going on. So, but this works if we delay half a second, and then we send the value. So this is the on value of the remote switch, same one as I used in the previous episode. And then after that we delay another second, and then we set the pocket switch to 1. So now we know that the switch is on. Or else, if this is not the case, then we send the same thing, delay 500 and delay 1000 after, and we send the off command. And these delays, somehow this fixes the thing that the receiver would stop the sender from sending because it receives the signal. So with these two delays it works. Without the delays, maybe we can tweak these delays a bit, I don't know. But without these delays, it didn't work as well, for me at least. And then just a serial print. So this is all that this sketch does. So let's upload this again and we'll look at the hardware. And the hardware for this sketch to work: on the Arduino we have our one shield this is a one shield for iPhone, so I connect that to my iPhone to tweet. And then on top of this we have a prototyping board with a receiver and a sender. And as I showed you in the last episode, again, plus and minus to both, and then the receiver is connected to pin 2, digital pin 2, because that is interrupt 0, and the sender is connected to pin 10. So here we have our pocket sender and a receiver. And let's have everything here. So this one doesn't show anything. We press this and now it turned on because we uploaded the sketch, and then we press again and after half a second it turns that switch off. So with one button we can turn it both on and off. Not too quickly though because of the delays. For the Twitter thing, we have our One Shield connected there, and this is the One Shield app. We go down, we turn on Twitter, and we look at this. We are signed in as Sorcery1, so this should work. And this is my Twitter channel, and this was the previous one. And if we press this button now, look, there's a tweet, Sorcery1, there is someone at your door. It says, read that, and if we just update, I think we need to update. There, I got a tweet, Sorcery1, there's someone at your door, go open it. I got it from myself in this scenario, but technically I could make a Twitter account for my door. So there we have it. So with this we now have buttons, really simple buttons, which takes about an hour each to build, of course, but except for that we have buttons that we can, with the help of an Arduino like this, with a few sensors and shields and stuff like that, do things both online if we want to do that and around the house. So a lot like those IOT buttons that is very popular nowadays. But this DIY variant, and that you can use for anything you like in your home. So I hope you like this video. As I said before, if you want to look at me cramming all these components into small compartments like this, there are links to those below, and I hope I will see you in a not so distant future. Until then, please subscribe, like if you liked the video, and hope you build something fun. Take care. Bye.